Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be studying Section 1 of Chapter 3, Relations and Functions. So in this section we've broken it into two parts. So our first part we're going to focus on understanding what functions are and identifying domain and range. So let's take a look at our first couple of examples and definitions. So first, let's start with some background information and definitions. So it says a relation is a set of ordered pairs. A function is a relation in which each input, or x, is assigned exactly one output, or y. So for each x, there's exactly one y that matches it in order for something to be called a function. So for each x, there's exactly one y. The domain of a function is a set of inputs. So domain are your x values. The range of a function is the set of outputs. So that would be your y values. By convention, inputs are x values and outputs are y values, as I've already stated a couple of times. So what we're going to practice doing this week is identifying your domain and range given tables, some maps, some ordered pairs, and then get into identifying whether they are functions or not. So let's look at our first problem, recognize domain and range. So part A says, what are the domain and range of the function? So first let's figure out the domain of our function. The domain is all of your input values, and your input always is your x values. So what we want to do, we want to list our values that go along with x. And I always list them from least to greatest. So when we do the values, we put those swiggle brackets or the braces, and we just list the numbers with a comma separating. So 1, 2, 3, 4, 5. And then I would close that with one of those braces. So I'm just simply listing all the numbers that fell in the x row. Now, in addition to identifying domain, you also have to identify the range of function. And range is always your outputs, which would be your y values. So we're going to list all the y values that we see in this row. But if a number repeats, we are not going to list it more than once. So for the range, I'm putting my swiggle bracket, and I'm going to say the range of this function, there's 11, 12, and 13. I'm not going to put 13 three times. I only need to list it one time. And that would be my domain and range of the function. So domain is simply listing what numbers are with x. Range is simply listing what numbers are with y. Now we're going to skip the next two problems because silly me, I put the same chart each time. So we're not going to do this 2 and 3 more times. We're going to go ahead and skip to problem 2, classifying relations and functions. So first thing we're going to do is read the directions. It says identify the domain and range of each relation. Then determine if the relation is a function. So the first thing I need to do is identify my domain. So my domain of a function is always the x values. It's the first number in a set of ordered pairs. So x for every single point is what I need to list for the domain. And always list from least to greatest. So my domain would be 1, 5, 7, and 8, because those are the 4 numbers that make up the x values of these points. The next thing I'm going to find is the range. The range is your y values. And again, I'm going to put them from least to greatest. So I'm going to start with -1 because that's my smallest y value, then 0, then 2, then 6. So I'm simply just listing what my x's are for the domain, what my y's are for the range. That's the first part. The second part then said determine if the relation is a function. So a relation is a function as long as none of the x values repeat. So if we look, the x values were 1, 5, 7, and 8. There were no repetitions, so I will say that this is a function. So is it a function? Yes, it's a function because none of my x values were repeated. So if we look at the next problem, problem B, or part B, we want to do the same thing. Identify domain and range and then determine is it a function. So domain is my x values. So I'm going to underline all the x values in each one of my points and list that for my domain. So we put those braces. So my domain, -2, 0, 4, 5. And then I need to focus on the range, which would be all the y values. Again, I'm going to keep listing them from least to greatest. So the smallest range that I had was 0.5. I had two 2.5s. So I'm only going to list it once. And then I had a 6.5. So the last thing once you list domain and range is determine is what you had a function or not. So look at your x's again, -2, 0, 4, and 5. None of those repeated, so we would say yes, that is a function. So what we're doing, picking out the x's and listing our domain, picking out the y's to list the range, and then looking back at your x's to see is it a function or not. So let's keep going with some more examples. So in part C, we need to identify the domain and range and then determine if this relation is a function or not. So first thing I'm going to do is my domain. So domain, you're narrowing in on your x values and we're going to list those. So my domain, I have 4, 5, and 6. And 6 shows up twice, but I'm only going to list it once. And then I'm going to pick out my range, which is all my y values. So again, from least to greatest, that'd be 3, 4, 5, and 8. So I figured out my domain and range, what were my x's and y's. Now I'm looking back at my x's to determine if this is or is not a function. Well, my x's repeated a 6, so this would not be a function. In part C. So let's take a look here at part D. We need to list the domain. So we're going to look at all the x values of the points and list them from least to greatest. So 4.2, 5, and 7. Notice I did not list 4.2 twice. I only list it once. And then once you have the domain, go figure out what is your range. So list all those y values. So I'm going to start with 0 because that's the smallest, and then 1.5, and then 2.2, and then 4.8. Once you list domain and range, look back at your x values. Did any of those repeat? Well, we had 4.2 show up twice, so this means it's not a function. So I'm running out of space. I'm going to say no, meaning no, that is not a function. So let's keep moving on here. Part E, identifying the domain and the range. So our domain, again, you're looking at the x values and putting them in those braces. So -2, -1, 4, and 7. And then we're listing those range values. 1, 2, -4, -7. So if I'm going to list them from least, I'll start with -7, then -4, then 1, then 2. The last thing is determine, is this a function? So my x values, none of those repeated. So yes, this is a function, because none of the x values repeated. All right, 3 more examples to take a look at. These are called mapping diagrams in F, G, and H, where you have a left side, all those numbers mapped to something on the right side. So what we're going to do, first we're going to list the domain. So the domain is your endpoints. That's what's not having an arrow drawn towards it. So that would be this set of numbers. So we're going to say the domain would be 1, 2, 3, 4, 5. And then your range is what has the arrow drawn towards it. So that would be what's over here on the right, which would be 17, 11, 10. Which actually I should have written it from least to greatest. So let's fix that. Actually, we should have written it 10, 11, 17. So from the mapping, what we want to do is make sure none of our x values were used twice. So each number should only have one line drawn from it. So 1, 2, 3, 4, and 5, all of those are only used once. So we would say that this is a function. So 2 more examples to take a look at. In part G, we want to identify the domain and the range of this map and then determine if it's a function. So first, let's look at the domain. That's going to be all the numbers on the left-hand side. What has the arrow being drawn away from it? So our domain, -2, 3, and 4. And then our range, that's what has the arrow drawn to it. So in this case, that would be 5, 6, 7, and 8. Now we just want to determine if it's a function or not. So we want to see, are any of the numbers in the left being used more than once? Well, I see the 3 has 2 arrows drawn from it. So that would mean this is not a function because the 3 input value was used twice. And let's take a look at our last example. We want to identify the domain and the range of this map. So we're going to start by listing our domain, which is going to be all the numbers on the left. So from least to greatest, that's 0.4, 2.3, 2.5, 7.1, 12.0. Then I want to list my range, all the numbers on the right. So that would be 0.5, 1, 2.25, 2.75 inside my braces. So the last thing to do is determine, is this a function or not? So if you look at the x's, we want to see, did any of these have one extra arrow drawn from it. They did not, so we would say this is a function because each x was only used one time. This concludes part 1 on our lesson of how to determine the domain and range of ordered pairs, tables, and mapping diagrams. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.